Okay, let's do some examples. And the first example I want to do is on page 251, number 14. Okay, let's do this is number 251, page 251, number 14. Okay, so it says find the probability that a female has a back to knee length greater than 24. So we want to know what's the probability that we'll have a back to knee length greater than 24 inches. Okay, we need to back up just a little bit and we need to get a little background on this problem. So if we look at the directions for the section, it says we have data for the back to knee length for males and females, and the distributions are both normal. So for females, it's a normal distribution with the mean of 22.7 inches and the standard deviation of 1 inch. What we've got here is now we can do our problem. So the first thing we need to do is we need to turn this into a z-score. So remember, we're going to have a raw score. We turn it to a z-score, and then we can find the probability either using the table or using StatCrunch. So first thing I'm going to do is find the z-score, and the z-score is my score minus the mean divided by the standard deviation. So when I do that, I get 1.3. So now what I'm going to do is I'm going to draw my distribution. I know for my z-score the mean is 0. 1.3 is going to be above that. And they wanted to know greater than, so I want to know this area that's above 1.3. So now I'm going to go to the table simply because I have it handy here. And when I have 1.3, the probability to the left is 0.9032. The probability to the right is going to be 0.0968. Now I'm going to leave it to you to see if you can find these numbers on the table or to practice using StatCrunch to find the same thing. And so to answer my question, find the probability that it's greater than. The probability that the knee length will be greater than 24 inches is going to be 0.0968, or I'm going to say about 10% of females have a back to knee length of greater than 24 inches. Okay, that makes sense. So now let's do number 16 on that same page. And this time we want to find the probability that a male has the back to knee length. So X is less than 24 inches but greater than 22 inches. And this is for a male. And we know that the males have a normal distribution, and I'm just using the Latin symbol for male, and the mean is 23.5 inches, and the standard deviation is 1.1 inches. Okay, so this is a betweener. So the first thing I want to do is I want to find the probability that my z-score is between 24 minus 23.5 divided by 1.1, and my units will be inches, and 22 minus 23.5 divided by 1.1. Okay, so now let's do that math. Okay, my low 36. Okay, so now let's go back and redo this. So my lower is going to be a negative 1.36. And my upper is still 0.455. And let me compute, and there I get my probability is 0.58853. Well, I had it to the 10th here, so I'm going to take it to the hundredths, so that would round to 0.59. So what I would say is that about 59% of the time a man has a back to knee length of between, and I'm putting it back into my original measurements, 22 and 24 inches. If I put it in z-scores, it doesn't make any sense to anybody. Okay, let's do another one. All right, let's do number 18. This time we're talking about the females, the same situation. So that means that we have a normal distribution, and the mean is 22.7, and the standard deviation is 1 inch. The first quartile, find the first quartile. So in other words, what they want us to find is they want us to find the place where the area lower than that is 25%. Now we know that the mean is quartile 2. So we know that our z-score here is going to be negative. All right, so let's look at this, and what I'm going to do is I can go in the body of the table, and since it's to the left, I can use the table as it stands, or I can go to StatCrunch, and I want to do standard, I want to do less than, I want to get rid of the z-score and put in the probability of 0.25. And I get that the z-score of quartile 1 is a negative 0.674. Okay? Now I have to unstandardize that. So here's what I'm going to do. I'm going to put it into StatCrunch and then simply unstandardize it. So I know z equals my score minus the mean divided by the standard deviation. Okay? I know the z-score is a negative 0.674. I don't know what the raw score is, but I know the mean is 22.7 and I know the standard deviation is 1 inch. So how am I going to solve this? I'm going to take both sides times 1. These cancel. That leaves me a negative 0.674 equals x minus 22.7. Well, what am I going to do? I'm going to add 22.7 to both sides. So that means my raw score is going to be 22.026, and it would be reasonable to round it to rounding rules, one more than what we were given. Okay, we were given the 25%, so let's round this to 22 inches. So 22 inches would be the raw score that is the boundary, the upper boundary for quartile 1. Let's look at number 20. So in this case, we usually use 0.05 for identifying significant values. But let's use 0.025. So if it's less than or equal to 0.025, it's significantly high. I'm just going to use SH for significantly. That would be low, sorry, or significantly high. So this is our probability. If our probability is okay, let's draw. So we're going to say it's significantly high if the probability equals is less than 0.025. It's significantly low if the probability is less than 0.025. Okay? So we want to find the female back to knee length is 20 significantly low. So in other words, we want to know is a back to knee length for a woman of 20, is this significantly low? So in other words, we want to find the probability. We find the probability finding the area to the left. So what's the first thing we do? We take our raw score and we standardize it. So we're going to take our 20 and we're going to standardize it using our z-score. R score minus the mean divided by the standard deviation. And then we're going to take that to either, we'll use that to find the probability. Okay, so we're going to do, oh, and remember for women it was normally distributed with the mean of 22.7 and a standard deviation of 1. So we're going to take our 20 minus 22.7. I think you can see we're going to get a negative z-score divided by 1. So it's going to come out to be negative 2.7. Okay, so let's take it to StatCrunch, and I want to put in for my x, I'm going to put in a negative 2.7. And I want to find the probability, and I put in less, and so the probability that I can put it a couple different ways. Z is less than a negative 2.7 equals 0.0034667. Okay, so this is less than 0.05. So since my probability is less than 0.025, then this is significantly low. So yes, 20 inches back to knee length is significantly low. Let's do number 26. So number 26 on page 252, we're designing a workstation, and so it must fit the range of people who fall between the 5th percentile for women and the 95th percentile for men. Okay, so I'm going to use a little color coding here. So let's do for women. We know that we're looking for knee heights. So women, it's normal with a mean of 19.6 inches and a standard deviation of 1.1 inches. And for men, they are normal with a mean of 21.4 inches and a standard deviation of 1.2 inches. Okay, so we're going to be finding the 5th percentile for the women and the 95th percentile for men. So let's go back and let's do the men first. So the 95th percentile is going to be somewhere up here, and we're looking for an area of 95% below whatever score that is. Okay, so let's find it, and if you were using the table, you would look in the body for the number closest to 0.95, and then you go out to the edges to find your z-score. I'm going to use StatCrunch, and I'm going to leave the value for my x blank, and I'm going to put 0.95 in for my probability, and I get that the z-score for this one is 1.645. Okay, now we need to unstandardize it, and if you'd like to memorize the formula for unstandardizing rather than just doing it, remember it is my raw score equals the mean plus my z-score times sigma. So I can put that in. My mean is 21.4. My z-score was 1.645. And my standard deviation was 1.2. And I'm going to get that is going to be 23.4 inches. Okay, now let's do this for the women. So, but this time we want to know the 5th percentile. So we want to know the z-score down here where there's only 5% below that. So we know, since the mean is 0, we know this is going to be a negative z-score. So again, I'm going to go to StatCrunch and I'm going to put less than or equal to. I'm going to leave my X value blank and I'm going to put in 0.05 for my probability, and I get a negative 1.645. So now I want to change that to a raw score. So my raw score will be my mean plus the product of my z-score times the standard deviation. So that's going to be 19.6 plus a negative 1.645 times 1.1. Now notice that my z-scores are the same. Just the signs are different, and that makes sense. If there's 5% down in this tail when it's a standard normal curve, that z-score will be the opposite sign of one where there's 5% in the upper tail. But our values are going to be different because we're looking at a different distribution. So let's go ahead and do this math. And our knee height is going to be 17.8 inches. It says, what is the minimum table clearance required to satisfy the requirement of fitting 95% of men? It has to be 23.4 inches tall. That would be the minimum. And then B says, the author is writing this exercise at a table of a clearance with 23.5 inches above the floor. What percentage of men fit this table and what percentage of women fit this table? Okay, so we have 23.5 inches. So let's do this when x, let's get a different color here. When x equals 23.5, what's the probability? Who can fit under it? So in other words, we want to know for men, what is this area if our x is 23.5? So let's standardize it. 23.5 minus 21.4 divided by 1.2. And when I do that, I get a z-score of 1.75. So what's the probability that the z will be less than 1.75? So I'm going to go back to my StatCrunch, and this time I know my value for the x, which is the same as z. It's a positive 1.75. I don't know the probability, so I'm going to compute, and that's going to be rounded. It's going to be 96%. So if we made the knee height of 23.5, 96%, or 95.99 is exactly what I got, of the men will fit under that. Now let's do the same thing for the women for the same table height. So this time my z-score is going to be 23.5 inches minus a 19.6 divided by 1.1. So my z-score comes out to be 20. Now if you look at table A2, you can see it only goes to 3.5, which is almost everybody. We're going to look at 3.54 on StatCrunch, and we get 0.9997, which rounds to the probability of this comes out to be 0.9998. So 99.98% of the women would fit in a workstation where the knee height was set at 23.5. Only 4% of the men wouldn't fit. So that's how you would do those types of problems.